Yes, I want to present now the SUSTAINair project. So as Stephen already announced at the beginning, this project is a very young project. So it started in January 2021. So the SUSTAINair project, as you can see on the left-hand side, maybe I will switch on a laser pointer. So as you can see here on the left-hand side, it's a nice picture. What is SUSTAINair? What does SUSTAINair deal with? So in contrast to this, what we have heard so far, you can see SUSTAINair is obviously a project which is related to aircraft and aircraft performance. And our goal is to contribute to zero pollution and to obtain a green planet, and this is done by a circular economy approach in aviation. Regarding this approach, I will show you later on what I'm meaning with this. So yes, of course, my name is Jürgen. I'm the coordinator, and Jesper from Invent will also give the second part of this presentation. So first the content, short introduction, then the overall concept of the SUSTAINair project, the circular aviation concept. Then I will give you a first overview of the work packages and how we plan to implement the project, and I will also present to the project partners, and then I will hand over to Jesper. So just for a short introduction, SUSTAINair is the abbreviation for Sustainability Increase of Lightweight, Multifunctional and Intelligent Airframe and Engine Parts. So we are 10 partners from 3 different European countries. The budget of the project is roughly €5 million, a duration of 42 months, and we started at the 1st of January of this year. We are addressing the greening of aircraft in the project, and this should be done by reducing the energy consumption during flight operations, first by reducing the masses and by increasing the aerodynamic efficiency. Here, this is, let's say, an overview picture or a sketch how SUSTAINair uses the four scope items of this MG35 2020 Horizon 2020 call topic to achieve impact. So in principle, we are working with morphing technologies. We design and manufacture innovative joints for aircraft materials. We manufacture and integrate structural health monitoring systems, and we also develop some new MRO and recycling methods. Therefore, we use 8 key enabling technologies, which we develop in the project. Then this leads to a demonstrator which having these favorable properties, and all together should or have to end up with some key exploitable results to make an impact in the circular economy in aviation. So to show you here the overall concept of the circular economy in aviation, in SUSTAINair, the project partners develop solutions to increase the resource efficiency and aircraft performance, to reduce waste and material costs for the total aircraft life cycle. And this life cycle is begins from the design to the manufacturing of and maintenance and repair, through the dismantling and recycling. And in SUSTAINair introduces this circular economy to the aerospace engineering to reduce material and energy consumption, thus contributing to a zero pollution across the entire value chain. So when we start here with raw materials coming into this circular economy approach, coming in some raw materials, some first life materials, together with some remaining materials from the recycling process. These remaining materials is pronounced as the second life materials. We start here the cycle with the design requirements, taking into account the first and the second life scenarios based on these design requirements, coupons and elements for aircrafts will be manufactured and combining coupons by joining technologies and introducing some damage diagnostic systems for the maintenance to extend to the components lifetime. And when the end of life of such an aircraft component is reached, then we have some automatic dismantling technologies which will be applied to maximize the amount of remaining material and thus to enable the second life for these materials. And again, the circle starts again. Here, just a short overview on the work packages, how we want to implement this. So we have here as a first work package, we have here this circular aircraft by design work package. Here is the PERT chart showing this work package where we design with fully recyclable materials and embedded functionalities, and where we design some aircraft coupons or components. These components or coupons will be manufactured in the following work packages, number 2, 3, and 4. This means number 2 is the manufacturing work package. Number 3 is the damage diagnostics work package, where we integrate functionalities into the aircraft components to also to have a look on if there is a damage or no damage or almost a damage of the coupon. And then the fourth work package is the joining and repair technologies work package for similar and dissimilar materials. And with all these work packages together, they result into the realization of a second life demonstrator, which is also fed from these design requirement work package. So this is the scientific and technological point of view, and this is conducted by the dissemination, exploitation, and communication activities, and by the management and the coordination work package. Just finally from my side to show you the partners. So we are here, all the partners together. You can see here we are the Austrian Institute of Technology, the coordinator. We have here RTDS Group on board as the dissemination, exploitation, communication responsible partner. And here we have a lot of different partners such as NLR working on composites, DLR working on titanium materials, uranium research, Johannes Kepler University from Linz, the Institute of Structural Lightweight Design. They are responsible for the damage diagnostics. We have here the TU Delft, acting here as a work package 1 as the circular design lead. We have here a company, Inocon, and also DTC. And finally, we have here the company Invent. Invent is a German company which realizes innovative composites and commercializes some new technologies. And now I want to thank you for your attention and want to hand over to Jesper from Invent, that he can present his or Invent's contribution to the SUSTAINair project. Thank you for your attention.
Yes, thank you, Jürgen. I hope you can hear me.
Yes, perfect.
Yes, great. Yes, as you just said, my name is Jesper de Wit. I'm a project manager at Invent. Invent is a SME with around about 100 employees in the middle of Germany. We are located in Braunschweig. Invent is a specialist in the developing and manufacturing fiber reinforced plastics. Mainly for the flying industries. We are a tier 1 supplier for the aviation industry, but also manufacture components for the space industry. But also we are manufacturing parts or components for other industries like the medicine sector or the automotive industry. We are also representing topics related to the research and development, and which is the department I'm working for. And together with the other business units of Invent, the R&D is constantly working on new systems, products, or systems for strengthening the competitiveness of Invent. Yes. This is also the reason why we are participating in SUSTAINair. Here we are researching a variety of topics, as you can see on the right side of this slide. Here are the topics of Invent representing the different work packages listed. For example, we are developing a structure for a morphing wing. We are developing a new concept for a recycled waste fiber material, which we gain from our production waste. And also we are developing further on developing existing ideas for innovative separation process for bonded joints. Invent has also the lead in the coordination of the manufacturing task for the demonstrators. Next slide, please. We expect several positive results from this project. I have listed here some bullet points. I don't want to go in detail in all the points, but highlight only the most interesting ones. For example, we will explore new insights on recycling of the FRP, the fiber reinforced plastic production waste, as I just said, which is obviously one of the important topics of the near future. We are investigating innovative repairing approaches, as well as the consideration of the first and second life of aviation or aerospace components, which is also an important topic for us for the next future. Because fiber composite materials have a long service life, and in some cases over several life cycles regarding the surrounding structure. So if innovative repair techniques are developed, they can be used for a correspondingly longer period, for example. And after this project, it will be possible for us to offer composites with integrated functional layers, for example, elastomers for morphing. This will lead to a gapless wings, for example, and thus an improved airflow can be realized. Additionally, smart structures can be developed for helping detect the detection of possible defects. Both use cases are seen here on the right. On the top is the morphing wing of a R&D project in the past, and below you can see demonstrators of Invent regarding the structural health monitoring technology. Next slide, please. In the past, numerous functional demonstrators for movable wings have successfully been developed by Invent and the consortium. And structural health monitoring could successfully be introduced into aviation-related demonstrators at Invent. This will be developed further on in SUSTAINair, and together with the additionally topic recycling and repair, we will bring, I will say, innovative and sustainable strategy to Invent. This will lead for us for offering new products with respect or regarding the social and economic topics of the future. The development of the combined solutions for the industrial composite materials. Also, we will offering for specific customers state-of-the-art solutions for the functional integration of sustainable materials, with regard to the circular economy. And I think this was the last slide. Yes, thank you very much for the possibility to introduce Invent and SUSTAINair, and thank you very much.